Welcome back to our deep dive into computer science and software engineering.
Yeah.
Today we're exploring Bayesian programming,
Uh-huh.
a topic that's making waves in our field.
It is, yeah.
It might seem theoretical at first, but trust me, it's already impacting how we design websites,
Right.
analyze data, and even write code.
Yeah. It's fascinating how Bayesian methods can be applied to this diverse problems.
Yeah,
We'll be using Bayesian methods for hackers as our primary source,
okay.
along with some insights from Wikipedia's entry on Bayesian inference.
The book's approach is very practical, which I appreciate.
Mm-hmm.
So let's start with the basics.
Okay,
What exactly is Bayesian programming?
sure.
And why is it so powerful?
So, at its heart, Bayesian programming is about updating our beliefs as we get new information.
Okay.
It's a way of quantifying uncertainty
Mm-hmm.
and refining our understanding based on data.
Okay.
Unlike traditional methods that rely on fixed probabilities,
Right.
Bayesian methods allow us to incorporate prior knowledge
Okay.
and adjust our beliefs as we gather evidence.
That sounds incredibly useful in a field like software engineering,
Yeah,
where we're constantly dealing with unknowns
right.
and evolving requirements.
Exactly.
Can you give me a concrete example of how this updating process works?
Sure. Imagine you're building a system to classify emails as spam or not spam.
Okay.
You could start with a simple model based on the frequency of certain words.
Okay.
But as you collect more data, you can refine your model,
Right.
taking into account factors like the sender's reputation
Hmm.
or the email's structure.
Yeah.
Each new piece of information helps us update our beliefs about what constitutes spam.
So it's like starting with a hypothesis
Yeah,
and then continuously testing and refining it
right.
based on the data we collect.
Exactly.
It's a very dynamic approach.
It is.
The book, Bayesian Methods for Hackers, highlights some interesting real-world examples.
Uh-huh.
One that caught my eye was analyzing the Challenger space shuttle disaster.
Right. A tragic event that underscores the importance of rigorous data analysis.
Yeah,
The investigation revealed that a failure of an O-ring seal in a rocket booster was a key factor in the disaster.
right.
A Bayesian approach to analyzing previous O-ring failure data
Mm-hmm.
might have provided a more comprehensive understanding of the risks.
It makes you think about how crucial it is to consider all available data
Yeah,
and continually update our understanding as new information emerges.
absolutely.
This approach could be quite valuable in preventing similar errors in complex software systems.
I agree.
The book also delves into how Bayesian programming can be used to sort Reddit comments from best to worst.
Yeah.
It seems like a surprising application.
It is, yeah. What's intriguing here is how Bayesian methods address the problem of small sample sizes.
Okay.
A product with a single 5-star review might be ranked higher than a product with hundreds of 4.8-star reviews.
Okay.
In a naive system,
Right.
Bayesian methods help us account for the uncertainty associated with limited data, leading to more reliable rankings.
So it's about giving more weight to rankings based on larger sample sizes?
Yeah.
Which makes sense.
Exactly.
Could we apply this to other areas of software development, like evaluating user feedback or prioritizing bug fixes?
Absolutely. Any situation where we need to make decisions based on uncertain data
Yeah.
could benefit from a Bayesian approach.
Okay.
The exploit-explore dilemma mentioned in the book highlights how we can balance using what we know
Okay.
with exploring new possibilities.
Right.
We need to exploit the best options based on current data
Right.
while still exploring other potentially better options.
That's a fascinating concept.
It is.
It reminds me of A/B testing,
Uh-huh.
which is commonly used in website design and marketing.
Right.
How do Bayesian methods offer a fresh perspective on A/B testing?
Well, traditional A/B testing often focuses on p-values
Okay.
and statistical significance.
Yeah.
Bayesian methods, on the other hand, allow us to quantify our uncertainty about which version is better and update that uncertainty as we gather more data.
Right.
This can lead to more informed decisions, especially in situations where data is limited.
So instead of just saying one version is statistically better, we could say we're 80% confident that version A is better
Exactly.
based on current data.
Yeah,
And that confidence level can change as more users interact with the system.
exactly. It's a more nuanced
Yeah.
and adaptable way of thinking about A/B testing.
Okay.
Now, before we move on to other examples,
Okay.
let's take a look at our second source,
Okay.
the Wikipedia entry on Bayesian inference.
All right.
It provides a more formal overview of the concept.
Perfect. A bit of theoretical grounding would be helpful here.
Yeah.
What are some key takeaways from the Wikipedia entry?
The article emphasizes that Bayesian inference relies on Bayes' theorem
Okay.
to calculate the probability of a hypothesis,
Mm-hmm.
given prior evidence.
Right.
This probability, known as the posterior probability,
Okay.
is then updated as new information becomes available.
Right.
This iterative process is central to Bayesian thinking.
It seems to align well with the scientific method,
Yeah,
where we constantly refine our understanding
right.
based on new observations.
Precisely. The Wikipedia entry also delves into different types of prior distributions,
Okay.
which represent our initial beliefs about the parameters we are trying to estimate.
Okay.
It's important to choose appropriate prior distributions as they can influence our results.
The article also mentions the Bernstein-von Mises theorem.
Yes.
What's the significance of this theorem in the context of Bayesian inference?
Well, the Bernstein-von Mises theorem assures us that as the amount of data increases,
Okay.
the influence of our initial beliefs diminishes.
Okay.
Our posterior distribution,
Mhm.
which combines prior knowledge with observed data,
Right.
will eventually converge to the true distribution.
Okay.
In simpler terms, with enough data,
Yeah.
the data speaks for itself.
That's reassuring, especially when there might be concerns about subjectivity in choosing prior distributions.
Right, the choice of prior is an important consideration.
Yeah.
And the Wikipedia entry acknowledges the ongoing debate
Okay.
between objective
Okay.
and subjective approaches to Bayesian inference.
Okay.
Objective Bayesians seek to minimize the influence of prior beliefs,
Right.
while subjective Bayesians believe it's valid to incorporate expert knowledge or other prior information.
Okay.
It's important to be transparent about our chosen prior and its potential impact on the analysis.
That makes sense. It's all about being aware of potential biases and understanding the limitations of our methods.
Exactly.
Now let's shift our focus to the practical applications of Bayesian inference.
Sure.
The Wikipedia article mentions its use in various fields.
Uh-huh.
What are some areas that stand out to you, especially in the realm of computer science?
Well, Bayesian methods have found their way into a wide range of computer applications, including pattern recognition,
Mm-hmm.
span filtering, and machine translation.
Right?
They are also being used in bioinformatics,
Okay.
for gene expression analysis and drug discovery.
Wow.
It's exciting to see how these methods are advancing scientific knowledge.
It sounds like Bayesian inference is becoming increasingly important in solving real-world problems.
It is. Yeah.
Are there any limitations or challenges we should be aware of?
One challenge is that for complex models,
Okay.
calculating the posterior distribution can be computationally intensive.
Right.
Approximation techniques like Markov chain Monte Carlo method
Mm-hmm.
are often needed to handle these cases.
Okay.
Additionally, as we discussed earlier,
Yeah.
the choice of prior can influence results.
Right.
So it's crucial to consider its potential impact.
These are important points to keep in mind.
They are, yeah.
So we've covered the basics of Bayesian programming, explored some real-world examples from Bayesian methods for hackers,
Mm-hmm.
and touched on the theoretical underpinnings from the Wikipedia entry.
Right.
What aspects of this have you found particularly interesting so far?
I'm particularly intrigued by how Bayesian methods can be applied to analyze and improve the code we write as software engineers.
Okay,
We'll delve deeper into this fascinating area in our next segment.
I'm eager to hear more about that.
Yeah,
Let's take a short break, and then we'll come back and explore how Bayesian programming can revolutionize software development.
sounds good.
Welcome back. Before the break, we were discussing how Bayesian methods
Uh-huh.
could be used to analyze
Right.
and improve the code we write as software engineers.
Yeah,
I'm really curious to learn more about this.
it's an area with immense potential.
Yeah,
Think about it. Code is essentially a set of instructions.
right.
And there's inherent uncertainty in how it will perform in different environments or with varying inputs.
Okay.
Bayesian methods
Yeah.
offer a powerful way to model and manage this uncertainty.
So instead of just testing for known scenarios,
Right.
we could use Bayesian inference to identify areas of code
Yeah.
that are more likely to be problematic
Exactly.
or inefficient.
Precisely. Imagine using Bayesian analysis in our compilers and testing tools
Okay.
to guide us toward more robust and reliable code.
Mm-hmm.
We could move from reactive bug fixing
Okay.
to a more proactive approach,
Yeah.
identifying potential issues before they even arise.
That would be a game changer for software development.
It would.
Reduce development costs,
Yeah.
increase software reliability,
Uh-huh.
and a better user experience are just some of the potential benefits.
Absolutely.
Now let's go back to Bayesian methods for hackers.
Okay.
One example that intrigued me was using Bayesian programming
Yeah.
to win on The Price is Right.
Right.
How does that work?
It's a fun illustration of Bayesian decision-making in action.
Okay.
The goal on the Showcase Showdown is to bid closest to the actual price of a showcase without going over.
Right.
Bid too low, and you might lose.
Yeah.
Bid too high, and you automatically lose.
So it's a delicate balance.
Yeah.
Of risk and reward.
It is.
Where does Bayesian analysis come out?
We can use a Bayesian model to represent our uncertainty about the true price of the showcase.
Okay.
We might have a general idea based on our knowledge of the prizes,
Uh-huh.
but there's always a degree of uncertainty.
Yeah.
The model allows us to incorporate our initial beliefs about the price.
Right.
And then as we see the individual items revealed during the showcase,
Okay.
we can use Bayes' theorem to update our beliefs.
So we refine our estimate of the price.
Yeah.
With each piece of new information.
Exactly.
That makes a lot of sense.
It does.
The Bayesian approach helps us determine the bid that maximizes our chances of winning.
Right.
By considering both our best guess about the price and our uncertainty in that guess.
Exactly.
That's a great example of how Bayesian methods can be applied to make optimal decisions under uncertainty.
It is.
Even in seemingly unlikely scenarios.
Right.
The book also mentions a winning solution for a Kaggle competition that used Bayesian methods.
Yeah.
Can you tell us more about that?
Kaggle hosts machine learning competitions where participants analyze large data sets to build predictive models and solve real-world problems.
Okay.
The competition in question, Dark World, focused on identifying dark matter halos in astrophysical images.
Okay.
The winning team used a technique called Bayesian model averaging.
What is Bayesian model averaging?
Sure.
And how did it help them win?
Instead of relying on a single model, which could be prone to overfitting the training data, they combined predictions from multiple models. Each model's prediction was weighted based on its posterior probability given the training data. This approach helps to create a more robust and generalized prediction.
So it's like combining the expertise of multiple specialists. Each with a different perspective to allow a bit of more comprehensive and accurate diagnosis.
Exactly.
I could see how this approach could be valuable in software development as well.
Yeah.
Especially when dealing with complex systems.
Absolutely. Imagine having multiple static analysis tools, each with its strengths and weaknesses. We could use Bayesian model averaging to combine their results, leading to a more thorough and reliable code analysis.
Now, you mentioned that Bayesian methods for hackers also explore strategies for stock market analysis. How can Bayesian methods help us navigate the often unpredictable world of finance?
While no method can guarantee success in the stock market, Bayesian analysis offers a more sophisticated approach compared to traditional methods that solely rely on historical data and often fail to account for uncertainty and ever-changing market conditions.
So how do Bayesian methods improve on traditional approaches?
Bayesian methods allow us to incorporate prior knowledge, such as expert opinions or economic indicators, into our analysis. We can also more effectively model the inherent volatility and uncertainty of financial markets.
It sounds like a more comprehensive,
a
nuanced approach
It is.
that considers a wider range of factors and acknowledges the limits of our predictions. What other intriguing applications are highlighted in the book?
One that stands out is the concept of Bayesian bandits.
Bayesian bandits?
Yes.
That sounds more like a probability puzzle than a real-world application.
It does, but it has real-world applications.
Okay, how do Bayesian bandits come into play here?
Imagine you're at a casino with a row of slot machines, each with an unknown payout probability. Your goal is to maximize your winnings by figuring out which machine is the most generous. This is the classic multi-armed bandit problem. Bayesian bandits offer a strategic way to tackle this problem by balancing exploration with exploitation. Instead of randomly trying different machines, we use Bayesian methods to update our beliefs about each machine's payout probability as we play. As we gather more data, we shift our focus towards exploiting the machines that seem most promising based on our updated beliefs.
So we start with a degree of exploration to gain information. And then transition to exploiting the options that appear most favorable.
Exactly.
This approach seems highly relevant to various real-world scenarios.
It is.
Like A/B testing or even personalizing recommendations in software applications.
You're exactly right. Bayesian bandits have proven incredibly useful in fields like online advertising and recommendation systems, where companies need to dynamically optimize their strategies based on real-time user behavior.
Right.
The core principle is the same, balancing the need to exploit known good options while continuing to explore for potentially better ones.
This has been a fascinating discussion so far.
It has.
And I'm starting to grasp the wide-ranging applications of Bayesian methods.
Yeah.
But before we move on, I'd like to touch on some key takeaway.
Okay.
From both Bayesian methods for hackers and the Wikipedia entry on Bayesian inference. What are some core concepts that our listeners should remember?
One key takeaway is that Bayesian programming empowers us to understand and navigate a world filled with uncertainty.
Yeah.
It's a framework for combining our prior knowledge with new data to make more informed decisions.
Okay.
Whether we're analyzing code, designing experiments, or even playing games of chance.
It seems to be a mindset shift from relying solely on fixed probabilities to embracing the dynamic nature of knowledge and constantly updating our beliefs based on evidence.
Precisely. Another important concept is the role of prior distributions in Bayesian inference.
Okay.
These represent our initial beliefs about the parameters we're trying to estimate, while the choice of prior can influence our results.
Okay.
The Bernstein-von Mises theorem provides reassurance that with enough data, the data eventually outweighs the prior.
That's a crucial point, especially for those who might be concerned about the subjectivity of choosing prior distributions.
It is.
We should also remember that Bayesian inference is inherently iterative.
Yeah.
We start with an initial belief, gather evidence, update our beliefs, and repeat this process as new information becomes available.
Right.
This aligns well with the scientific method.
It does.
And encourages a continuous learning process.
Exactly.
So it's about embracing uncertainty,
Yeah.
learning from data, and constantly refining our understanding.
Right.
Are there any potential pitfalls or challenges we should be aware of?
For complex models, calculating the posterior distribution can be computationally challenging, requiring approximation techniques.
Right.
We must also acknowledge that while Bayesian methods provide a powerful framework, they are not a magic bullet.
Okay.
The quality of our results still depends on the quality of our data and the assumptions we make.
Those are important points to keep in mind.
They are, yeah.
So we've covered the theoretical foundations and explored various real-world applications of Bayesian programming. In our final segment, I'd like to discuss the broader implications of these methods for the future of software development and computer science.
Sounds good.
Welcome back to our deep dive into Bayesian programming.
Yeah.
We've seen how it helps us make smarter decisions in a world of uncertainty.
Right.
But what does this mean for the future of our field?
Right.
Computer science and software engineering.
It's an exciting time to be thinking about these questions.
Yeah.
We've touched on how Bayesian methods can be used to analyze code, potentially leading to more robust and reliable software.
Right.
But let's push that idea further.
Okay.
Could we use Bayesian inference to predict bugs, optimize performance, or even automatically generate code?
Those are some bold ideas.
They are, yeah.
How would we even approach something like predicting bugs using Bayesian methods?
We could start by building models that take into account various factors known to contribute to bugs. Such as code complexity, the experience level of the developer, or the frequency of changes to a particular module. As we collect data on bugs found in existing systems, we can use Bayesian inference to update these models and identify patterns that might indicate a higher likelihood of bugs in new code.
So we're essentially using historical data to train a model that can assess the risk of bugs in new code.
Exactly.
That's a fascinating concept.
It is.
Could we also apply this to performance optimization?
Absolutely. Instead of relying solely on intuition or trial error, we could use Bayesian methods to systematically explore different code optimizations. Imagine a system that could automatically suggest code changes based on a Bayesian analysis of performance data. This could significantly speed up development cycles and lead to more efficient software.
Those are compelling examples.
They are.
But the idea of automatically generating code using Bayesian inference seems almost like science fiction.
Right.
How realistic is that?
It's certainly a challenging area. But researchers are making progress. Imagine a system that could learn from existing code repositories and use that knowledge to generate new code that meets specific requirements. Bayesian methods could play a key role in building such systems by enabling machines to reason about code structure, functionality, and intent.
It sounds like we're talking about a paradigm shift
Yeah.
in how software is developed.
Right.
Moving from manual coding to a more automated and intelligent process.
Exactly.
Guided by Bayesian principles.
That's the exciting potential of Bayesian programming in our field.
Yeah.
It's not just about improving existing methods. It's about reimagining what's possible.
Right.
And pushing the boundaries of software development.
This has been an incredibly insightful deep dive.
It has.
We've explored the theoretical foundations of Bayesian programming, seen its practical applications across diverse fields,
right,
and even glimpsed its potential to revolutionize software development.
Yeah.
What are some key takeaways you want our listeners to walk away with?
Well, I hope our listeners gain an appreciation for the power of Bayesian thinking.
Okay.
In a world filled with uncertainty.
Right.
It's not just a set of mathematical techniques.
Yeah.
It's a way of thinking about problems.
Okay.
Incorporating evidence and making more informed decisions.
And as we've discussed, it's a way of thinking that has the potential to transform how we approach software development.
I agree.
Leading to more reliable, efficient, and even intelligent systems.
It's an exciting time to be involved in computer science and software engineering.
Yeah.
I encourage our listeners to explore the resources mentioned in this episode.
Okay.
Bayesian methods for hackers and the Wikipedia entry on Bayesian inference.
Right.
And to continue their exploration of this fascinating and rapidly evolving field.
Thank you for joining us on this deep dive into Bayesian programming. Until next time, keep exploring, keep learning, and remember, there's always more to discover in the ever-evolving world of computer science.
Absolutely. 2219